In this video, you're going to learn how to develop a Spring Boot application using microservices architecture. This is going to be a highly practical tutorial, so to follow along, I expect you to have at least a basic understanding about Spring Boot and basic understanding of what microservices architecture is and why you use them. So we'll be building a simple online shop application using microservices architectural patterns, using mainly Spring Boot and the latest Spring Cloud technologies. So we're going to cover all the interesting and important architectural patterns like service discovery, centralized configuration, distributed tracing, event-driven architecture, centralized logging, and much more. If you're not aware of what are these fancy terms, don't worry, we'll cover this in the tutorial. So before going ahead and implementing our microservices, let's take a moment to understand what is Spring Cloud. Spring Cloud is a project under the Spring Projects ecosystem. So it's another project like Spring Boot, Spring Data, Spring Security, or any other Spring project, but it mainly concentrates on helping us to build the reliable and robust microservices. It provides us a common set of design patterns which are implemented already, like the configuration management, service discovery, circuit breakers. And there are many other patterns which are implemented into the Spring Cloud project. We'll have a look at it in depth in this tutorial. You don't need to worry about that. We are going to use Spring Cloud to mainly develop the microservices. That's what you need to know. As you understood what is Spring Cloud, now let's go ahead and check what are the different services we're going to build in this tutorial. So the first service we're going to build is going to be a product service. So this service provides us an API to create and view products in our application. And it also acts like a product catalog where we can view all the products inside our application. So the next service is going to be an order service where we can order the products which are available in the app. And after that, we are also going to have an inventory service where the order service can check if the product is in stock or not before submitting the order. And lastly, we're also going to have a notification service where we can send email notifications after the order is placed successfully. And out of these four services, we are going to mainly have the order service, inventory service, and the notification service talk to each other. We mainly have the asynchronous and as well as the synchronous communication as part of these three services. So now let's go ahead and check the overall solution architecture of our project. Alright, so this is how the solution architecture diagram looks like. So mainly we are going to first look at the services we are developing. So we have the product service, which is talking to MongoDB, and an order service, which is talking to the MySQL database. And the inventory service is also talking to the MySQL database to store all the inventory information. And we have the notification service, which is like a stateless service, which it does not have any database, but it is responsible to just send out notifications to the users. If you're talking about a microservice architecture, you cannot call it as a microservice architecture if the services are not talking with each other, right? So here the order service is talking to the inventory service. So whenever an order is being placed, we'll first check whether the inventory is available or not by making a synchronous communication. And after that, we are also going to send out the notification once the order is being placed successfully. So for that, we are going to make an asynchronous communication with the notification service. If you're not sure what is synchronous and asynchronous communication, don't worry, we will also cover this in detail in this tutorial. For asynchronous communication, we are going to use Kafka. And coming to the outside world, we have the surrounding services which enable the microservice architecture. We have the API gateway, which acts like a gateway to send the requests from the user to different services. So for example, if I am a user and I want to communicate with the product service, I don't want to give the host name or the IP address of the product service to communicate with it, right? So the API gateway acts as like a gatekeeper to send out the requests to different services we like. So our applications is also being secured using the authorization server called as Keycloak. We'll also have a look at it in the detail. And other than that, we also have different services like Eureka. And we are going to use Grafana Stack to implement observability. We are going to use Grafana Loki to aggregate the logs from our microservices, and we are going to view these logs in Grafana using Grafana Loki. We are going to use Grafana Tempo for distributed tracing, and we are going to use Prometheus to collect metrics, and finally we are going to use Grafana to visualize the metrics of our applications, of our services in a beautiful dashboard. Finally, we are going to containerize all the services using Docker and we'll run all the Docker containers first using Docker Compose, and then we will migrate this Docker Compose workloads to Kubernetes. And again, don't be overwhelmed with all these details. We will have a look at each of them in detail in this tutorial. Alright, so if you'll have a look at the logical architecture of each of the services, we have a controller, service, and a repository layer for each of the services. So in the controller layer, we will be receiving the HTTP request from the clients, and from there the business logic is being executed on the service layer. And in some of the services, we are also going to communicate with a message queue. So that's why we have this message queue communication, and mainly in the order service, we are going to make use of the message queue and also the notification service. And after that, we are also going to store the information in the database. So for that, we are also going to maintain a repository layer, which mainly talks to the database. So we have MySQL and also the MongoDB database. So both of them will follow the same pattern. We'll have a repository which talks to the database. This is how almost all the services are being structured. So we'll follow the same process for all the services we have. All right, so now it's time to coding. The first thing I'm going to do is to create the product service project. I'm going to open start.spring.io project website. This is where we usually generate the starter for all our projects. So first of all, for the project, I'm going to create a Maven project. I'm going to select Maven as the build tool. And of course, we are going to use Java as a language. And for the Spring Boot version, as of creating this tutorial, the latest Spring Boot version is 3.2.4. So I'm going to select that version. For the group ID, I'm going to type in as com.techie.microservices. And for artifact ID, I'm going to provide it as product service. And the description is going to be called as product service. You can type any description you like. The package name, I'm going to just provide as com.techie microservices and product. I'm going to remove the service here. I'm going to choose the packaging type as var, and I'm going to choose the Java version as Java 21. Coming to the dependencies, first of all, I'm going to add the dependency of Lombok, and next we are going to add the dependency for Spring Web, as we are going to create a REST API. Next, we have the Spring Data MongoDB, as we are going to interact with the MongoDB database for the product service. And lastly, we are going to add the test containers dependencies, because we are going to also write integration tests for the product service. So once this is done, I'm going to click on the generate button. This will download a zip file to your machine. And the next thing you have to do is unzip the zip file and open it in your favorite IDE. Alright, so before we go ahead and start coding, we need to have Docker installed on your machine. So for that, just search for Docker in Google, and I'm going to click on the icon Get Docker. And here, based on my operating system, I'm going to download Docker. I'm going to choose Docker Desktop for Mac, as I'm running on a Mac machine. So if you're using Windows, you can just use the Docker Desktop for Windows, or if you're using Linux, of course, you can use Docker Desktop for Linux. So once this is installed, we will first go ahead and see how to download MongoDB using Docker. And specifically, we'll be using Docker Compose to download the MongoDB database to our machine. All right, so now I'm inside the location where the product service source code is downloaded. So first I'm going to unzip this file, and after that I'm going to open this code in my IntelliJ IDEA. So I'm going to click on the open button here in the IntelliJ, and then select the product service folder, and I'm going to trust this project. And once the project is loaded inside the IDE, I'm going to first make sure that the project is downloaded correctly by running a Maven command. So for that, I'm going to click on this Maven icon to the right side of the IDE, and I'm going to click on this execute Maven goal button, and I'm going to run the command maven clean verify. So this will first download the necessary dependencies to our local machine, and then we'll start to build the project. And as you can see, the project is built successfully. That's good. So now let's go ahead and download the MongoDB database as we told before. So for that, I need to create a Docker Compose file. So for that, I'm just going to right click on the product service root project, and I'm going to click on new file. And I'm going to create a file named docker compose.yaml. And here I'm going to create the necessary code to create the configuration and create the necessary configuration to download MongoDB. So for the Docker Compose file, I need to first start with the version of the Docker Compose file. I'm going to use the version 4, and after that I'm going to add the object for services, and for the service I'm going to create the service with name MongoDB. So I'm going to create the service name as MongoDB, and here you can see that our GitHub Copilot is already suggesting me the necessary configuration for MongoDB Docker Compose. So I'm just going to make use of that, but I don't want to use this configuration. I want to change this configuration a little bit. So for image field, I'm going to use the Docker image called Mongo, but I don't want to use the latest tag. I want to use a very specific tag. So the tag is going to be 7.0.5. Select this tag, and the container name, I'm going to leave this as MongoDB, and I'm going to expose this Mongo container on the local port 27017, and the MongoDB itself will be running on the port 27077 inside the container. And also I need to add another object called as environment, where I'm going to add the MongoDB username and password for authentication. So I'm going to add the property MongoDB Mongo initDB root username and Mongo initDB root password. I'm just going to change the password to password. I'm also going to add another parameter environment variable here called Mongo initDB database, and I'm going to call the database as product service. And lastly, as MongoDB is running inside a container, whenever you stop the container, all the data you have inside the container will be lost. So for this reason, we have to provide a volume folder where the Docker container stores all the necessary files or data inside our file system. So after all this configuration is added, I'm just going to open the terminal, and I'm going to run the command docker compose up -d. So the -d will start the Docker Compose in the background, so we don't see all the logs. So if I just press enter, you can see that the Docker Compose is running, and the MongoDB container is started automatically. So for me, it's almost instantaneous because I have the MongoDB image in my local Docker registry. But if you're running this command for the first time, you can expect a small delay because the Docker Compose will download the MongoDB image from the Docker registry, and it may take a minute or two depending on your network speed and the machine you're running. The first thing we have to do is to configure the MongoDB URI inside the application.properties file. I'm going to give the database name as product service. If you want a detailed explanation on how to configure Spring Boot with MongoDB, have a look at the Spring Boot MongoDB playlist in my channel. You can also find this in the description section. After that, we have to create our domain model, which is the product class. So let's create a package called as model. And inside the package, I am going to create a class called as product. To define this product as a MongoDB document, I'm going to add the document annotation to the top of the product class. And I'm also going to add the Lombok annotations to generate the getter-setter methods and the constructors. Inside the class, I'm going to create the required fields, which are ID, name, description, and price. And to the field ID, I'm going to add the ID annotation from Spring Data to specify that this is a unique identifier for our product. And to store this product inside the database, we have to create a Spring Data repository. For that, I'm going to create a package called as repository, and inside this package, I'm going to create an interface called as product repository. And I'm going to extend this interface with the Spring Data MongoDB's Mongo repository interface. and I'm going to pass in the generic argument as product, and for the identifier I'm going to pass a string as the second generic argument, because this is the type of the ID field in our product class. Now it's time to create the controller class. So for that I'm going to create a package called as controller, and inside the package I'm going to create a class called as product controller. As we are exposing a REST API, we have to add the REST controller annotation to the top of this class, and also the request mapping annotation with value /API/product. So now let's create the API to create the products. So for that I'm going to create a method called as public void create product, and this method, as this creates some products, we are going to send a post request for this method. So I'm going to add the post mapping annotation, and as a response we are going to type in response status, and we are going to send out the HTTP status as created. So I'm going to select HTTP status created, right? And as a request body, we are going to receive the product information. For that we are going to create a new class called as product request. I'm going to use this product request. So instead of using a class, by the way, as we are using Java 21, instead of using a class, we can also use a record type. So for that I'm just going to create a record called as product request, and this is going to be inside package called as DTO. So I'm going to select the destination package as DTO, and I'm going to click on OK. So now we have the product request record. So this product request takes in almost the same values as the product class. So we need an ID, name, description, and a price. So let's also type these fields inside the record. So I want to have a string ID, I want to have a name, description, and a price. So the price is going to be of type big decimal. So after creating this record, now we can go back to our controller, and here we need to write the business logic to create the product. So I can directly use the repository, access the repository from the controller itself, but this is not a good practice, because usually all the business logic should be inside a service class, inside the service layer. So for that reason I'm going to create a new class called as product service. So I'm just going to right click on the main package, and I'm going to create a new class called product service, and I want to create this inside a separate package called as service. So if you add also the package name while creating the class in IntelliJ, like for example service.productService, IntelliJ will automatically create this product service class inside the service package, right? So let's see that. So I'm going to select class, and I'm going to press enter, and you can see that the product service class is automatically created inside the service package. So now I'm going to add an annotation called as service, as this is a service class, and for this, inside the service class, I'm going to first inject the product repository interface. So I'm going to write private final product repository, and now IntelliJ is complaining that we need to add a constructor for product repository and initialize the product repository inside the constructor. So we can do that using a Lombok annotation. Either we can create the constructor manually like this, or we can do that using Lombok. So I'm using so I want to use Lombok for this, because then you don't need to write this boilerplate code. So we can do that by adding this required args constructor annotation. And now inside the product service, I'm going to create I'm going to add code to create the product. So here GitHub Copilot is already automatically suggesting me the code. So let's use the code here, and then I will explain to you what is happening inside this method. So now you can see that we are taking the product request record as the input argument for this input parameter for this method. So I'm just going to import the product request DTO, and here we are creating the product class, the object for product class, and we are providing the name and we are mapping the name coming from product request to the name field of the product class. So here, instead of writing product request.get name, what we have to do is we have to write product request dot name, because to access the fields inside a record, you can directly access them using the field name. You don't need to write getters and setters for record. So that is one of the advantages you have by using records, right? So I can do the same thing also for the description. So it's going to be product request dot description and product request dot price. So now we have a logic to create the product object from the product request. Now we have the code to save the product to the product repository by adding this product repository dot save method. And after the object is saved to the repository, I'm just going to add a log statement like log.info product created successfully. So this log variable is not available for us. We can use the SLF4j annotation from Lombok to create a log variable so that we can use the logger to add the log statements. So now we can go back to the product controller, and I'm going to inject the product service into the product controller. So for that, I'm just going to add required args annotation on top of the product controller, and I'm going to define the product service variable. So I'm just going to import the product service, and I'm going to take the product service variable, and I'm going to call the create product method inside the product controller. So now we have our endpoint ready. So we have a controller that takes in the request body of type product request, and is going to pass it to the create product method of the product service. And the create product method is first creating an object by mapping the fields from the product request record, and then finally saving it to the product repository. So the next thing we are going to do is to return the product we have created from this method. So I'm going to add return product to the end of the method, and I'm going to change the return type from void to product. And let's go back to the product controller and also add a return statement and add the return type as product. I'm adding this product as a return type because I want to have some response back whenever I make a call of post call to create the product. I want to see a response of the product I've created, right? So this usually includes the details, right? So I want to see that as a confirmation that the product really is saved. So that's why I'm changing the return type to product. So the next thing I'm going to do is to create another endpoint to read all the products. So for that, I'm just going to create a get mapping, and I'm going to add the response status annotation, and the response status for this endpoint is going to be 200 HTTP status OK, and this method is going to be public. It's going to be a list of products. I'm going to import the list class from Java util package, and this method is going to be called as get all products. And here I'm going to use this product service dot get all products, and this get all products method does not exist yet in product service. So I'm going to create this method inside the product service, and here I'm just going to call product repository dot find all, and then I can just return all the products which are present in the database. One improvement I can do here is, instead of returning directly the product class, it's actually our domain class. What we can do is we can create another DTO called as maybe product response, and we will map product object to the product response object, and then we can return that product response as a return type. So let's go ahead and do that. I'm going to right click on DTO package, and I'm going to create a new record again, and I'm going to call this as product response. And this product response contains the ID, name, description, and the field price. And this price is going to be of type big decimal, right? So let's go back, and here instead of returning a product object, I'm going to return a product response object. And what I have to do now is to map this list of product objects to list of product response. So for that, I'm just going to add .stream map, and I'm going to map this to the product response object. So for that, I'm just going to create a new product response object, and I'm going to call this product.getID, product.getName, product.getDescription, product.getPrice, and at the end I'm going to call toList, so that we get a list of product response as the return type. So now let's go back to the getAllProducts, and here we have to change the return type of the getAllProducts from list of product to product response. So now let's also refactor the createProduct endpoint to return the product response instead of the product class. So I'm just going to change the return type to product response. Let's also go to the createProduct method and change the return type to product response. And here also let's copy the same object here. Let's copy the same code here and paste it here inside the createProduct method. All right, so now it's time to test our implementation. So first I'm going to start the product service application. So let's open the product service application, and I'm going to start the application in the debug mode. And IntelliJ is asking me to enable the annotation processing. I'm just going to click on the button, and now you can see that the application has started successfully on the port 8080. So now to test our two endpoints, I'm going to use Postman. So the first thing I'm going to do is I'm going to create a post call for the URL http localhost 8080/API/product, and I'm going to provide the JSON body. So the name is going to be iPhone 15. The description is going to be some text about iPhone 15, and also I'm providing the price. Right, so let's click on the send button and see what is the response we'll get. Okay, looks like we are getting an error. Let's see what is the problem. So let's go back, and okay, you can see that we are getting an unauthorized exception, because if you open the Docker Compose file, we are providing a username and password for the MongoDB, but in our application.properties file, we are not providing any authentication information, right? So let's change the MongoDB URI to include the authentication. So we can enhance the MongoDB URI by providing the username and password. So after MongoDB // just before the localhost, I'm going to add the username as root. I'm going to add a colon and then add the password as password, and I'm going to add the symbol @ right? And to the end, I'm also going to add the auth source as admin. Okay, because the username and password is going to be created in the admin collection, and by adding this parameter, we are asking Mongo to authenticate to take this username and password and authenticate it against the admin database. So now let's restart our application, and then let's try to call the endpoint again. All right, so now you can see that the create is successful and we got back the response. This is the manual test. Well, let's create also an integration test, an automated test, where we can run our test during the build, right? So for that, I'm just going to open the product service application test class, and here we are going to write integration test for our two endpoints, the create endpoint and the read all products endpoint. So for that, we are going to make use of test containers. If you're not aware of test containers, it is a library which will spin up Docker container for us. We can create a Docker container for whatever library we want, whatever database or message queue we want. As we are using MongoDB, we can use a real MongoDB for our test. Instead of using some embedded MongoDB, we can make use of a real MongoDB with the help of test containers, and we can spin up this test container. We can spin up this Docker container during our test process, and we can connect to this containers as part of our tests. So I opened the testcontainers.com website, and here you can see that test containers is an open source framework for providing throwaway lightweight instances of databases, message brokers, web browsers, etc. Right? You can run about anything that can run in a Docker container using the test containers. So it provides out-of-the-box support to many modules. So if I click on modules here, you can see that there are many different kinds of modules which are supported by test containers. So if you want to run integration tests against Elasticsearch or maybe Kafka or RabbitMQ, everything is available through the test containers module, so you can make use of it. For our test, we are going to make use of the MongoDB module. So if we go back to a project and click on the pom.xml, you can see that we have already added by default, as we already selected the test containers option in the start in the Spring Initializer website. We already got this dependency out of the box, so we don't need to add any other dependencies, any other external dependencies. So we can go ahead and start writing our tests. So let's go back to the product service application test class, and here I'm going to first change some configuration inside the Spring Boot test annotation. I'm going to provide the web environment value as random port, because whenever I am running the integration test, the test will spin up the application, and by default it will run on port 8080, and I don't want to do that, right? I want to run it on a random port because it can conflict with the existing processes which is running. For this reason, I'm going to ask Spring Boot to run this test in a random port. So for that, I'm just going to provide the web environment as random port, and inside the test, I'm going to rename this test of context load as should create product. And this test is supposed to actually create the product, and then we will verify if the product is created successfully or not. So the next thing I'm going to do is to initialize a MongoDB test container. So I can do that by typing static MongoDB container and new MongoDB container, and I'm going to provide the Docker image name. So the Docker image name is going to be Mongo, as we saw before in the Docker compose.yaml file. We have provided the image name as Mongo and the tag as 7.0.5, right? So I'm just going to copy this and use the same configuration also here. So now I'm going to add one dependency to the pom.xml, mainly to make REST calls from our integration test. So for that, I'm just going to go to the pom.xml file, and I'm going to inside the dependencies tag, I'm going to add a dependency called as rest assured. So for that, I'm just going to type the group ID as io.rest assured, and artifact ID should be rest assured, and the version of this dependency as of now, the latest version is 5.3.2. so I'm going to add this dependency and click on the Maven icon to the top right corner, so that Maven will download this dependency to my local repository. So once this is done, I'm going to go back to the test class. So here what I'm going to do is I'm going to set up rest assured inside this test. So for that, I'm going to add a before each annotation, and I'm going to create a method called as setup. And here I'm going to, so here first I'm going to define the base URI of our application, where base URI where our application will be running. So I'm going to define rest assured dot base URI equals to HTTP localhost. I'm not going to use 8080 because as we are using a random port, we have to dynamically check which port our application is running. So for now, I'm just going to define the base URI as localhost, and I'm going to define the rest assured port. And to define the port, I'm just going to add one annotation called as local server port, and I'm going to define private integer port. So what this annotation will do is, whenever the application is running, it will inject the port on which the application is running into this variable, right? So now I'm going to configure rest assured to use this port. So I'm just going to call rest assured.port is equal to the port integer variable, and once this is done, the configuration to use rest assured is completed. Now we have to also start our MongoDB test containers before running the test. So for that, I'm just going to add a static block, and inside the static block I'm going to add MongoDB container dot start. And one last thing we have to do is, whenever the application, if you open the application.properties, you can see that we are setting the MongoDB URI. We are setting the host name as localhost and the port as 27017. We also need to define this property while running the test. Test containers comes with an annotation which will dynamically assign the MongoDB host and port while running the application. So we can do that by adding this service connection annotation. So by adding this, you don't need to manually specify the MongoDB URI. Spring Boot will automatically inject the relevant URI details for our application.properties for MongoDB. Okay, so now we are ready to create our test. So first of all, I'm going to create a product. For this I need to have access to the request body. So I can just go to the Postman request we have done before, and I'm just going to copy this request. I'm just going to reuse this request body, and I'm going to define this inside this test class. So it's going to be string request body equals, and here I'm going to make use of multi-line strings, which was introduced in Java 14, I guess. And here you can define the multi-line string, and I'm just going to paste this with the JSON copy. So now we have a request body ready. Now it's time to call our endpoint in the product controller. So we have to call the /API/product endpoint with HTTP method as post. So for that, I'm just going to type in rest assured dot given dot content type is going to be application JSON, and here I'm going to type in body as a string, and this is going to be a request body, and I'm going to type when I'm doing a post request. So for that, I can type in post /API/product, and I can write then I want to have the status code as 201. I want to also assert the fields inside the response body by adding some matchers. So I'm going to type in .body, and I want to check that the ID field is not null. So I can do that by adding matchers dot not null value, and body, again I'm going to check the name field is equals to iPhone 15. So I'm going to use matchers from Hamcrest, and using the equal to method, I'm just going to check if the name field is iPhone 15 and the description is iPhone and I'm also going to assert the description, and finally I'm also going to assert the price. So let's go ahead and run this test and see if our test is successful or not. All right, that's great. You can see that we see the logs product is created successfully, and if you observe the logs inside the product service application test, you can see that we can see the logs. Our test is connecting to the Docker, and as I already have the MongoDB image on my local machine, it's actually just started the test instantly. But if you don't have this Docker image, then the test will first download the Docker image and then we'll run the test.